I'm going to number 14, the very next one, just because it's a looped limacon, and I want to do one example of a looped limacon. So we can tell it's a limacon because it's a plus b sine theta. And then a over b is 2 over 4, which is less than 1. And so we know that it is a inner loop. All right, so it is a sine. So let's talk about symmetry. Test for symmetry over here. Is it symmetric to pi over 2? Usually is. Here's me testing it. The answer is yes, it is. Okay. So symmetry is theta equals pi over 2. And let's calculate our maximum R values. We are going to use -1. It's nice we just have a sine theta. So we have -1 gives us an absolute value of -2, and a +1 gives us an absolute value of 6. So 6 is our largest number. And where will that happen? Put 6 in for R, solve it, you get sine theta equals 1. So it happens at sine theta equals pi over 2. So we know we have 6 pi over 2 as a point. So 6 pi over 2 is way up here. You can see on the graph now I'm putting the orange point in. Go to our zeros, set R equal to 0. We get sine theta is -1/2. Where is sine theta equal -1/2? At 7 pi over 6 and 11 pi over 6. So I know I'm coming down to zeros at 7 pi over 6 and 11 pi over 6. Now, because it's symmetric to theta equals pi over 2, I am going to just use these points. This guy, this guy, this guy, this guy, this guy, this guy. And I'm not going to use the 12s this time because these limacons are usually bigger. They're not petals, little tiny petals. So I'm going to just use negative pi over 2 and then these guys. Okay? So here we go. Negative pi over 2 is -2. So here's negative pi over 2, and I have to back up to -2. So that's that point appearing right there. It's going to be my little inner circle. I can tell I already have a point out here. So now I have a point in here. So there's your inner loop. At negative pi over 3, okay, so that's this point right here. I back up to -1.5, so I get this point. And because of symmetry, I have a point here. And at negative pi over 4, I get negative point. And this is such a small graph, it's hard to do this, but I have a little point there and a little point there. And then at negative pi over 4, I did use the negative pi over 4, I'm at 0. And one of the reasons I did that is because I had zeros there. And, negative pi over 6, sorry. It's 0. So here's your negative pi over 6, which is your 11 pi over 6, right? There's your 0. So we have our inner loop done. And now I'm moving along. I've done, just so you see, sorry. I've done this point, like this point, this point, this point, and this point. And now, no, I haven't done this point. I haven't done 0 yet. At 0, we get 2. So I have a point right here at 0. At pi over 6, I get 4. So now, I didn't do my symmetric one at 0. So there, I have one across the axis. At pi over 6, it's 4. So I have a point here and on the other side. And at pi over 4, it's 5.4. So I have that. So pi over 3, get it here and here. And so we have our outer circle. Okay, so that was an example of an inner loop and an outer loop. All right, I'm going to go do one more, I think. Yeah, spiral of Archimedes. I skipped to number 18 in your notes. So go to number 18, you get R equals 2 theta. You see there's no trig function. So here's how you do that. First of all, you know that it's a spiral of Archimedes, okay? And now that will have no symmetry, and it will have no maximum R values because it keeps getting bigger and bigger. And the 0 is going to equal 0 in this case, because if you substitute 0 in for theta, you get 2 times 0, which is 0. So here we are. We still have to graph it, and so you really want to use y1 equals 2, and then, you know, you would use x, right, on your calculator. Because if you look at your variable button, it has everything. You see it says x and theta and all that. So, okay, make sure you're in radians. Put in pi over 6, and I'll just go through these. You get 1.04. So I'm getting a point here. And then at pi over 3, it's 2.1. And then 3.1 at pi over 2. And then you can tell I'm just going around putting these dots in. They get bigger and bigger and bigger and bigger and bigger. And you just got to go all the way to 2 pi. So then draw your best spiral that you can coming off of there. So these are pretty easy to graph. Okay, so that was the notes for, I don't think it'll do any good for me to just keep doing more examples because the setup is the same. All right, you find all those things it tells you to find, and then you graph it. And that's the whole point of this lesson. All right, so give your homework a try now.